Today we're going to look at section 9.5, apply composition of transformations. What composition of transformations refers to is multiple transformations. So for example, we might do a translation and then a reflection, or we might do a rotation and then a translation. So there's multiple items happening. So we're going to take everything we've studied and just apply it to one problem. Excuse me. So the very first item, though, is a very specific composition, and it's called a glide reflection. So you might want to pause the video when you write this down. A glide reflection is a translation followed by a reflection in a line that is parallel to the direction of the translation. So the word glide, think about like a hang glider. That's your translation. And then the reflection part, it reflects over a line. So you might pause it and copy that down, and I will talk about in example 1 why it's a glide reflection. Okay, example 1 says the endpoints of segment CD are 1, 2, and 5, 4. Graph the image of segment CD after the glide reflection. So I have two things I'm going to do. So I'm going to do a translation and then a reflection. So I'm probably, I guess let's go ahead and plot these 2 points, and I'll do this in 2 different colors or multiple colors here. So 1, 2, and then 1, 2, 3, 5. Okay, so I have C and D. So I'm going to name them without primes because it's the preimage. Now, to do the translation, I'll probably do this in red. I'm probably just going to count. Actually, I forgot to make my segment. So make your segment. Okay, so when I look at the directions here, I'm doing x minus 4. So I'm going to travel to the left 4 units, and then I'm just going to stay where I'm at for y. I'm not going to go up or down. So if I take C, I'm just going to count 4 to the left. 1, 2, 3, 4. Okay, so I'm going to call that C prime, and then same with D. 1, 2, 3, 4. And connect. Okay, so there is my translation. So this is the glide part of a glide reflection. Okay, so it shifted or translated to the left. Now the other one, I don't know, maybe I'll do it in purple. The other one is a reflection in the x-axis. So you also could count here, or you could write the rule out. I prefer to do it on the graph where I count. So I'm reflecting over this axis. So however far above the x-axis my points are, I count that many below. So C prime would, if it's 2 above, C, the new one will land here. And we're going to call this C with 2 marks. I would say C double prime. D is 1, 2, 3, 4 above, so 1, 2, 3, 4 below. D with 2 primes. And there's the reflection part. So it's called a glide reflection because it translates and then reflects. And the directions here at the top say it's followed, followed by a reflection in a line that is parallel to the direction of the translation. So what that means is the direction of the translation was this way, and then that is parallel to the line we reflected over. So that's in essence what a glide reflection is. I will just give you the 2 items you need to do, but I just want you to be aware of what a glide reflection is. Okay, let's move on. Number 2. We need to translate. Looks like I'm using the same segment. I'm going to do a translation and then a reflection. So I'm going to start again by going back and graphing those 2 points. So 1, 2, and then, 5, 4. Okay, so I've got, let's see, C prime, D, or not prime, I don't know why I'm doing that. It's just C. Let me get rid of that. Oops, come on. All right. C and D. Okay. I'm going to just go with red again. So I'm going to translate So my x doesn't move, it just stays, but my y, get rid of that arrow, the y is counting up 2. So I'm going to take C, I'm not going to go left or right, I'm just going to go up 2. All right, so there is C prime, and then D is just up 2. Okay, the next one, reflection. So if I'm reflecting in the line x equals 2, I need to graph that line. So if you want to graph, if you remember where x equals 2 goes, great. Otherwise, I'm going to graph or make a table. So if x is equal to 2, all of my ordered pairs contain x equals 2. The y values are not impacted. So I just randomly put 3 numbers in. So if you go to plot that, 2, 1, 2, 2. So it makes a vertical line. Now, you might have already known that. So if you don't need to make the table, don't worry about it. So this purple line is what I'm reflecting over. So I'm going to call that x equals 2. Okay, so let's do the reflection. I'll do it in green, actually. So I can, even though it's a segment that crosses, I can look at my points C prime and D prime, and however far to the left my line is, I'm going to count that many to the right or vice versa. So C prime is 1 unit to the left. That means my new point will land here. So we'll call that C double prime. D prime is 1, 2, 3, so I will go 1, 2, 3 the other way. And so that would be D double prime. So when I connect, what ends up happening is when your line of reflection goes over the item you're reflecting, it like flips over on top of itself, so to speak. All right, so there is my final picture. Okay, let's keep going. Number 3, the vertices of triangle ABC are as follows. Graph the image of triangle ABC after a composition of the transformations in the order they're listed. I have a translation and a reflection. All right, I'm going to start by graphing. Okay, A, B, and C. So 3, 1. 1, 5. And then 5, 3. Okay, since it's a translation, I like to count with my points. If you want to plug it into the ordered pair, that's fine. Okay, so I'm going to go x plus 3. I'm going to go to the right 3 and down 5. Plus 3. So I'm going to go for A. 1, 2, 3, down 1, 2, 3, 4, 5. A prime. B is going to go over 3. Then 1, 2, 3, 4, 5. I know my A is kind of in the way, but that's okay. And then C is going to go 1, 2, 3, 1, 2, 3, 4, 5. All right, ABC. Okay, so translations just slid a little bit down and to the right. Okay, my reflection. So I like to count reflections. So make sure you are thinking about the correct X or Y axis. So I just am going to highlight this just to make sure I'm looking at the Y. So I'm just going to count all of my points are on the right. I'm going to see how far they are from the line and count that way to the left. So I'll just start with B up here. It's 1, 2, 3, 4. So I'll go 1, 2, 3, 4. C is, I'll start with C prime. 1, 2, 3, 4, 5, 6, 7, 8. And then I need to do that again. 1, 2, 3, 4, 5, 6, 7, 8. And then A. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So there's my final image. So if you needed to do ordered pairs, I mean, you could do it all on the graph and then write down the ordered pairs. It really just depends on the format of the question. Okay, let's keep going. Just got a couple more. Okay, number 4 says, vertices of triangle ABC, I've got the same triangle. Graph the image after the composition of transformations. Okay, so I have a translation and then a rotation. So I'm going to go ahead and plot A, B, and C again here. 1, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay, C. Okay, translation. All right, so when I translate, I am going to go -6, negative on the x-axis, positive on the y. So I will count 6 to the left, 1 up. 1, 2, 3, 4, 5, 6, 1 up. 1, 2, 3, 4, 5, 6, up 1. 1, 2, 3, 4, 5, 6, up 1. All right, so now I'm doing a 90-degree rotation. So without giving me what direction, it is assumed to be counterclockwise. So I'm going to think through my shortcut. If I'm counterclockwise, the original y and x switch spots, and since counterclockwise goes to the left, the number on the left. Now, I like to do this with ordered pairs. So I'm actually going to write down these 3 ordered pairs so I can see them. So A is at -3, +2. B is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So that's a -5, +6. And then C is at -1, 1, 2, 3, 4. Oops. Okay, so I'm going to go ahead and just write down the ordered pairs. A, double prime, B, and C. And then we just follow the rule. So my new point would be -2, -3. And then the next one would be -6, -5. And then finally, I would have -4, -1. So I could go ahead and graph it, and that would give me a good visual. So -2, -3. -6, 5, -5. And then -4, 1, -1. Okay, so what I see is I went like this. Okay, that's counterclockwise. And then I can just double check. I see the 90 rotation. Okay, so you don't have to do that last part. I just like to double check that I've followed it along correctly. Okay, if you want to move on, maybe try the next one. There's really just one more example, so why don't you try that one and then pause the video and then come back. Okay, on this last one, I think maybe I'll just do it with coordinates and then I'll graph. So you can do it, really any way you want to, especially since I see the first rule is a rotation. So when I rotate 180, my shortcut is to change the signs basically. So F prime is going to be -4, +4. And then G prime is going to end up being -1, +2. So all I did was just change the sign. Now the reflection, I might just think through what it would look like. So if I use my graph here, if I'm reflecting over the y, like let's say I'm reflecting this point, it's going to end up over here. So the y coordinate's going to stay as the same number, but the x coordinate will change sign. So I could say -x, y. the x-coordinate will switch sign, the y stays the same. So if I followed that rule, f double prime would be positive 4, positive 4. G double prime would be positive 1, positive 2. So I'm going to just go ahead and graph it just on this one just to make sure it did what I expected. So actually, let me graph in purple. So 1, 2, 3, 1, 2, 3, 4. Okay, this is F. G is at 1, negative 2. So my first rotation here went to negative 4, positive 4. Okay, that's good. That's where it should go. And then negative 1, 2. Okay, so that did a 180. Now the reflection, negative 4, or positive 4, positive 4. So the only thing I checked for, make sure I went over the correct axis. So that did reflect over the y-axis. And so there is G double prime. Okay. So if you can do graph and then write ordered pairs down. You can just go through all the ordered pair rules. You really can go through whatever, makes the most sense for you. Okay, that is it for composition of transformations.